So good morning to everyone. Here from Vienna, from the Energy Community Secretariat. This is our third webinar this year. We started slowly. Let's see how this will lead us in the autumn season. Here, idea was to start from actually. I have to admit, we tried with the speakers how it's going on, and then it ended up that the host is not able to run his own presentation. But yeah, we will manage. So what we have in Energy Community Secretariat, we started with DSO platform for DSOs for gases, and through this platform we had communication and meetings and webinars and so on. What happened in the meantime, that this new gas package is coming on horizon, first of course for European Union, and then it's very close for the energy community contracting parties. It's not so immediate, but nevertheless it will come, and countries and companies have to be prepared. That's why we decided to go in serial of webinars to actually start from technical knowledge and technical practice which already exists in European Union and globally. And that's why we are really very grateful to find experienced and excellent presenters and with huge knowledge already in implementation of many things. Because there are going to be a lot of webinars and a lot of events where this new legal package is going to be explained, and what policymakers, regulators, and then of course companies have to do. So it's all about preparation for the future. That's why knowledge for future. In a sense that certain experiences and technologies and techniques already exist, and we have also people to show and to share this with us. So today I am very glad that we can host and learn from two speakers from Endress and Hauser company, from Mr. Norbert Meszaros and yes, Hundrieser, but you will see in their slides and from their speech what is all about. In March, we were tackling energy efficiency and how actually to use waste pressure in the system for certain applications. In May, we were focused on gas quality and how to control entire process when biomethane, being gaseous or liquefied, is entering into the system. And today is entire focus on green hydrogen and application, how to produce it and how to utilize it. And with that, I will give the floor to Mr. Norbert Meszaros, and later on, I believe, to Jens Hundrieser. And here we have requests from presenters. Be very active, raise your hand immediately when you see and you spot something on the slide, which would you like that it's clarified. We have enough time, we have 1 hour, so it's important that all questions are addressed, and there is no need to wait till the end. So with that, I will give the floor to Norbert and to Jens.
Yep, thanks a lot, Carolina. I will share my screen now, and then we will do the joint presentation. Can you see our screen now? Just please, can you see it now?
Yes, we can see it all fine. You just
okay. Yeah, Norbert first. So I think you can say some welcome words, and then I will take over. But I think I give you the first words.
Okay, I think then you can show the next slide, please.
Yeah.
Because we prepared introduction slide. First of all, thank you very much for the invitation. This is my honor being here today. We prepared a general overview of the production process of green hydrogen. We will start with some theoretical background, and in the end, this is about an online tool you can use manufacturer independently, providing a lot of process knowledge as well. Producing green hydrogen is a quite complex process, starting from the water preparation through electrolyzer and so on. We will see today, and I wish you an interesting time with us.
Good, then I take over. Thanks a lot, Norbert. You will get for sure the presentation afterwards. I also, on the first, also a barcode where you can also then get some brochures. My name is Jens Hundrieser, and also thanks from my side to having the opportunity to show what is at the moment ongoing in the green hydrogen production and utilization with practical examples. It's a PowerPoint slide, but you will see we have a lot of customer realized examples in there. I think you can read our both history with Endress and Hauser. And now I just would like to come to agenda. We have a short. We are relatively sure that Endress and Hauser is known. However, probably some things are not yet known, so therefore short overview. Then, I mean, green hydrogen is used, can be used in different areas. We focus today in terms of industrial sector use at the end, where hydrogen brings a reduction of CO2, ideally to down to net zero. Then we have a little bit more into the details in terms of green production overview. We have some references offering. We want to show you that basically in 4 different types of electrolyzer, whether it's alkali, whether it's PEM, whether it's high temperature or the combination of alkali and PEM, we are in different application at different customers. Then comes an overview about this applicator, we call it. It will be a web-based selection guide for applications where you see it really the first time. It's not 100% ready, but this would be at the end a little bit to show more details than in the presentation. Norbert will talk basically about what, from my experience, typically some customers only know that we have a package for gas analytics solution. There are application example for the hydrogen usage, whether it's purity and quality control and also then blending. And then there will be a summary. Okay, Endress and Hauser, when you will get it, we had 70 years of anniversary last year. And here's a little bit of an overview. I'm 34 years with the companies now. I still like it a lot because it's a family-owned company, a big family. When I started 34 years ago, we were 3,500. Now the family has grown to 16,500 plus. I don't go into the details. You can also look it on the website. I mean, what we show, we are very innovative, which you see later. I hope that you agree then. So we have 8,900 patents and patents filings. We have more than 1,300 people of the 16,000 in the R&D and so on. And also some other topics here. I come to the end to this EcoVadis rating at the end, what this means. So this is a little bit of an overview from last year, which may be interesting. When Endress and Hauser started 71 years ago, we had this product, which is capacitance. I mean, I can also probably put this laser here, the laser pointer. This is better to see. So we started with this, and now I don't go into detail. But when we come to green hydrogen production, there are level devices, there are flow devices, which are important
Sorry for
for the
interruption,
process.
Jens. We just see the very first slide.
Huh? This is strange. This is strange. I don't know why.
We also, yeah, now it's the second one or the sixth.
Oh, okay.
But we don't see the presentation mode. We just see the presentation like in presentation mode.
I have a presentation mode there. You don't see the presentation mode? No.
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 This is, I don't know. This is strange.
Most likely you are sharing the wrong picture or window.
Yes.
No, I have. Yeah, okay. I do it again. Stop sharing. It worked before. So I go in here. Then I share again. For the window. And this. Now you see the slide?
The slide, yes, but not the real presentation mode. Maybe
but this
you
is,
can
step. I'm in
manually.
presentation mode now. But you cannot see the presentation mode.
No, just the slides in another view.
But for that, I can say that maybe it's more important that we see the slide, and each of us on own screen can go and make a bigger view. Then the entire slide will be visible.
Yes.
Not
so let's start
to
from the
lose
beginning.
time, but now it's important that slides are going on. Although we are really on the sixth slide.
Okay.
So.
Okay. Good. I mean, you get it afterwards. I don't go to the facts and figures. You should see now our portfolio, correct? You see?
Yes.
Portfolio. So what I mentioned there, later on, if we go to grow green hydrogen production utilization, there will be key measurements for the level, for the flow, for the liquid and gas analytics, for the pressure, for the temperature, and more. So this is the overall program for all industries, for process industries, where we go zoom down later to specific applications. Yeah. One thing which we like to show shortly is the Hartwig technology, because it's one of the biggest differentiators, and especially electrolyzer suppliers, they like it. What does it mean? There is a chemical industry which has a Namur NE 107, and they had a wish some years ago that instrument supplier do it like in an automotive, like in a car. So there is permanently process and device diagnosis. You get also symbols like in a car. And this we have for all new instruments. So therefore you have it permanently checked. I compare it with a car now. When you go with a car to check your car if this is okay, we have a verification, and this verification is not a calibration. It's a device stays in the process, and basically then it's a check if to a high percentage. For flow device, for example, we have 95% of all sensors and electronics can be checked. And the benefit is that especially for critical application, which you have also in green hydrogen, where you have functional safety, explosion proof, or if you want simply to show that the device which is in, let's say, your flow device is working like at the beginning, there this verification is used. We have also certificate from the TÜV, which is a certification body. So long story short, especially in remote application, and electrolyzers will be put somewhere on the planet, this is a good possibility besides a permanently process and device diagnosis to say, I would like to check now if this flow device, this level device in an application which is critical or important. We do not speak about the standard application in water. We speak about the application in the gas separator, which you see. We speak about the flow application of what hydrogen is produced. So application which are very important for the process. And then you have with a high probability the document that says this device is working like at the beginning. To make it very short, it's an indicator how much you can trust the individual device in an individual important application. There's more information which we can share. And just to add. Then we have also for individual applications some data for monitoring, for predictive maintenance. This may be an application in an electrolyte where you then want to see if you have build-up or corrosion or so. So this is then the other possibility. I just want to show shortly this heartbeat technology helps for especially important / critical applications to really have a certain knowledge how much you can still trust the device which is installed remote or after a certain years. Before I come to the hydrogen part shortly, and here a short overview. Industrial sectors, cement, steel, ammonia, and ethylene, they are the most greenhouse gas emitters. And if we look at the topic of decarbonization, there are other possibilities. I'm a hydrogen fan. I speak about hydrogen every day. However, I'm also realistic. There are other possibilities to reduce CO2, and this I want to show with this slide. It's a relative old study, 2018, but it's still valid. So if you have the target in industrial sector to reduce the CO2, you can use a circular economy, for example, in steel. You have the recycling. You have possibilities to use electrification, to offer savings based on energy efficiency improvements, process optimization, electrification is standing here. So long story short, my message is hydrogen is a key element for the decarbonization in industrial sectors.
A question or comment.
Yes.
Yeah, the question, are you still on slide 6 or did you go further?
I went further. I don't know, but it's not working. Can you see the slide 8 now?
Yes.
Yes.
Then it's an issue here with the WebEx when I do a presentation mode. Now we have it because when you
get out from presentation mode and
yeah, I did already. So now yeah. Thanks for asking me. So then I will not do. Then it's some issue with the presentation mode. Yeah, this was a slide before which you then couldn't see with the heartbeat technology, but you get it in the handout. And I will not go to presentation mode. Thanks for the feedback. So this slide you can see. You can see it now 8, correct?
Yes.
Good. Thank you. So basically what I mentioned here, focus on hydrogen, but there are other possibilities and also everything which helps to reduce CO2 is absolutely important. Yeah. So this is our, hopefully you see now slide 9, a hydrogen production utilization ecosystem where for sure green hydrogen means to use renewable energy. A lot of people speak about sun photovoltaic and wind. Sometimes I always say, please also think about hydropower because this is also renewable. It's very important. And Norbert and me, we would like to show you our instrumentation package for electrolyzers, then also gas analytics examples, and also a usage example for gas turbines in blending of hydrogen. We don't have the time to go into every details, but for sure there are different types of electrolyzers. I mentioned at the beginning, I like to show you 4 examples. One is the oldest, longer than the principle of alkali electrolysis, is much older than 100 years. You have always water purification, demineralization, where lots of measurement can be found. Key parameter is conductivity, because if you have a good water purification, you will get also a good hydrogen quality outcome. So there are different parameters. Meanwhile, we have also discussion with electrolyzer supplier to have some parameters for stack optimization, to say how long the stack lifetime is, or if you have some impurities. This is a topic where, for example, for PEM electrolyzer, proton exchange membrane, solid electrolyte electrolyzer, not the alkali one, we have parameters like TOC, total organic carbon, to really see something happening in the electrolyzer, which is come back impurities in the water. Focus today is on the electrolyzers process. Here you see alkali, and then something is done with the hydrogen. For example, it goes to the compression. I mean, there are alkaline pressurized electrolyzer, which already offer 30 to 40 bar, like the PEM, and the atmospheric alkaline electrolyzer. So at the end, it depends for what you want to use it. And focus today is at the end the electrolysis process, but with the process diagrams later, we can also show you more. So this is an example. We have the first installation 2012-13 in electrolyzers, but they were really small. And this is also not a big one. This is 1 megawatt electrolyzer in a hydropower plant. You see here, this is not a container because they have they have space and time to install this in a hall. So here we have typical measurement, conductivity measurement for the purified water, together with a vortex flow meter, because it's non-conductive. You cannot use magnetic flow meters. And then the electrolyte with magnetic flow meters and temperature and pressure and much more instruments here. As one example, this is one regional alkaline electrolyzer project where we, because we produce here also in southwest of Germany, we are part. You see a little bit alkaline electrolyzer. It's called modular because all the companies bring different modules together to have this electrolyzer. And here's the gas separator where you can see a level measurement, guided wave radar, liquefied. Here you see the flow, here you see the temperature. So this is another example for alkaline electrolyzer instrumentation. Then we go to the PEM. For all this application, we have material when you're interested. These are customers that we can give the name, like this is HTech Systems PEM electrolyzer, where we have an article with some instrumentation around. And this company is a lot of times used, or PEM electrolyzer are used a lot directly when you have a very dynamic wind farm, and you directly put them here, because compared to alkaline electrolyzer, the PEM electrolyzer are quite fast in storage and also in offering the hydrogen, and therefore they can also be in future used for stabilization of the grid, because they offer a lot of fast changes possible. The next one is a high temperature one. These are used, for example, in steel industry. So in compared to alkali and PEM, there's no water as an input here, it's a steam. And this is one example where mostly flow devices are used. You can also create synthetic gas. It's a high temperature electrolyzer as a number 3. And then later on, when Norbert will take over, we have a reference for gas analytics as at an AEM, there's an alkali and PEM combination where we have then done different measurements. This is the overview, which I would like to jump in later after Norbert's part. So these are 260 measuring points, 27 process diagrams, which is about of 2 man-years of work to put it together, from the water preparation, then for sure the renewable energy. We have hydropower. This is a module which will be linked. In the middle we have alkali and PEM. High temperature is going to follow, and then we have the hydrogen processing, storage. We have here one realized example. I don't know if it's interesting for you, but in Germany we won a big project for a hydrogen salt cavern storage. There are plans, I don't know in Europe totally, but in Germany, because if you have a hydrogen infrastructure with pipelines, with production, key is the storage, and salt caverns are key for the storage, and there are planned a lot of numbers of the salt cavern storage over time, and we did supply one of the first here. Here comes the blending, which comes later, and I come zoom in here later. One guy which I have met once and I learned a lot, it's Professor Michael Sterner. He has wrote a book, if you have time, 700 pages. It's always good before sleeping. And he explains the whole power to X sector coupling terminology, examples, and very interesting. I don't have anything, but this is a handbook, 700 pages, which I can recommend to look if it comes to power to gas, power to fuel, and so on. These are typical process diagrams which we have soon online. And I just want to highlight here you have the alkaline stack, and then afterwards you have the wet hydrogen and the oxygen. And similar, you have the PEM stack. So these are all the measurement which make sense. I give you an example. Nowadays, unfortunately, I have to say, most of the oxygen is not used because you can use the oxygen for oxy-fuel burner, you can use it for hospitals, you can use it for wastewater treatment plants, for the aeration. So then this measurement are not there, because if you don't use it, you just ventilate it out and then you don't have it there. And then we have different measurements in the separator. This measurement I would like to show a little bit. One customer said, and we have not thought at this, we have a lot of measurement which are standard, some are modified. But here the customer said, we want to have the differential pressure between the hydrogen and the oxygen separator, which means on one side, the differential pressure measurement sees 100% hydrogen. And one thing which I can say, when you have 100% hydrogen, not 10%, 100%, pressure devices were very thin membranes that need a gold coating for living long time. So on one side, we have here the differential pressure with the gold coating. On the other side, we have the oxygen, and oxygen application means cleaning, but cleaning is not enough. I mean, cleaning may be enough in a factory for automotive where you have not in parallel the hydrogen. You need to have the cleaning and material which are listed. In Germany, we call it Bundesanstalt für Materialforschung. So it's a German association for material science. This material for oxygen have to be listed and the site have to be cleaned. Just one product which we got the question, and then everything which we have realized, we put in these applicators here. Process diagrams. Now comes the product portfolio. You saw at the beginning the huge portfolio, and this is now a little bit broken down to the production of green hydrogen. Very important message is if you or someone looks at the application, it always is a question what we ask to you: what functionality do you need? So we have flow basic functional devices, or we have transducer for pressure. So per individual application, it makes sense to discuss together what accuracy, what functionality do you need, explosion-proof functional safety to adapt or to really make this product fit for the application, that you pay not too much. On the other side, that you get what you want. So this is magnetic flow devices for electrolyte. Vortex is typically used for the demineralized water. Coriolis for the output of the hydrogen. We have more instruments which may fit, but these are the typical ones. Then we have pressure transducer, pressure devices. This is a full package with explosion proof, with functional safety, with heartbeat, with everything. And the same applies to temperature from the transducer to the device. Then we have, for the especially gas separators, typically guided radar are used for the continuous measurement. There are alternatives. Some customers like differential pressure. It depends also on the application. Some like even capacitance probes. So this is what we will do in the web version. We will always give per application our best practice #1 choice. And then we will give up to 3 alternatives, which means here in this case, #1 guided radar, alternative 1 differential pressure, alternative 2 capacitive, and that's it. We have no alternative 3. Tuning fork is typically the one and only from our side for the gas separators. For sure, we have different functionalities, but this is then the one which we use for limit switch. We have a full package of liquid analysis with parameters like pH, like conductivity, like TUC, like silicate, depending how the water quality has to be. And now I'm giving the hand over to Norbert, because these two gas analysis and gas composition measurements are the key for the next slides to explain from Norbert.
Thank you, Jens. Please stay on this slide. I'd like to add something. Based on our experience, more and more project integrator companies ask for hydrogen-ready application. How can I prepare my system? Which sensors are capable for hydrogen readiness? And this is not so easy. Of course, considering the pressure and temperature devices, you can put right now gold-coated pressure devices, and you can be hydrogen ready. But considering the flow measurement devices, it's not so easy, because for delivering the same energy, then you may face 2 to 3 times higher flow velocity, and it would decrease the flow dynamics measuring ranges drastically. So there are certain points to consider for the future. And now, next slide, please. I will start with brief overview about optical analysis. In this part, we will be focusing on hydrogen processing. Maybe you have heard in the previous time a lot about hydrogen purity, different classes, 3.8, 5.0, typical for the mobility, or for the semiconductor production up to 7.0. What does it mean? This purity grades are quite high, and with the standard devices, there are some limitations. We used to receive inquiries. I'd like to purchase an analyzer for measuring hydrogen purity, and we have to change the logic, and we used to ask questions. Where does this hydrogen come from? Are we talking about green hydrogen coming from PEM electrolyzer, or does hydrogen come from the steam reforming? Why? Because we need to know which impurities we expect. Because for the impurities in the background hydrogen, we can provide the devices they match. Because if we consider the quality 5.0, we are talking about the lowest PM measuring ranges. Here in the picture, you can see the hydrogen processing chart in 2 steps, and in the applicator you will find 2 the most important parameters. The first one is moisture in the hydrogen, and the second part is oxygen in the hydrogen. These are the standard parameters used to be asked for, and we propose the optical analysis solution for the moisture, TDLAS, tunable diode laser absorption spectroscopy, and for the oxygen, the quenched fluorescence technology. What is common in these devices? They react very fast. They are very robust and reliable. Reliability is a key point because mostly we are talking about accuracy. Accuracy is important, but it's not enough. I was discussing with different associations in the previous month for creating position papers for introduction for the government for the future requirement for hydrogen measurement. And I raised my hand and I asked them, is it enough measuring with the best accuracy, or do we need maybe something more? And yes, for sure. And as mentioned, predictive maintenance, proactive health check is a key factor, because we are talking about very complex processes, and we need to ensure the proper functionality. So these optical devices, these are from the spectroscopy. This is generally use of the absorption, emission, or scattering of electromagnetic radiation. In case of TDLAS, we use the absorption. This is depending on the analyte, on the optical wavelength, for sure, and the concentration. This is a very robust device. You can see right in the middle. We had a test project in Austria. We made a comparison against the chilled mirror dew point measurement. You can use this concentration measurement also for dew point, because this is only a calculation. And I said we don't want to use a brand new device. We took a demo device, 3 years old, was calibrated only once in the factory, and was traveling around the world every month, installed, shipped to the next use. And with this initiative, we wanted to prove the robustness of these devices. And in the end, we got a reference rating. In case of oxygen measurement, we are talking about the quenched fluorescence effect. On the tip of the sensor, there's a special layer, and depending on the concentration of oxygen, the fluorescence effect will be quenched. It means on the chart, light intensity and time for the same intensity, the same intensity lasts shorter, practically. So this effect will be quenched, and this provides very good information for the oxygen concentration. Again, it lowers the concentration, so in the trace level. Next slide, please. Here you can see picture, not only the sensors, but also so-called sampling systems. The sampling systems are crucial. Based on our experiences, 90% of any problems come from the sampling system. Therefore, you need to be very careful if you decide designing your own sampling system. There is an opportunity getting plug-and-play solutions, and this is a headache-free option. Next slide, please. Here you can see a real photo of an application with some more technical option of measuring ranges. This is the basic option for the typical electrolyzer hydrogen quality verification. It fits to mobility requirement like 5.0, and the dimensions are also quite compact. And here you can ensure the quality is the right one. Next slide, please. And this is a real reference application. So we are not showing only test projects. This is a real project from Germany. The customer was very satisfied. On the picture, you can see additional sensors like QMax, mass flow measurement for hydrogen flow, pressure transducer, sweet coat coating, and as an integral part of the system, the analysis cabinet is there. in the most cases with the DSOs or final operators, we are not in direct contact. However, it's very important to know what's happening within the systems, because for later operation, for service, for additional questions, we are ready to be asked, and we are at your disposal. I invite you to scan later this barcode. You will get much more information and videos of the experiences and much more detailed technical data. Next slide, please.
Maybe one sentence to add. This is the testing for the gigawatt factory that this company Enapter is building. So this whole setup is basically to test every produced of this small electrolyzers which are put together, if they really bring this 99.999% 5.0 quality, just as an additional point.
Thank you, Jens.
Welcome.
Yes, and another application. The most questions were, can I replace simple gas chromatography for gas analysis by Raman spectroscopy? Raman spectroscopy uses the scattering effect. Raman laser light interacts with the molecules, and the photons will be scattered and are shifted in the spectrum, and based on which molecules you have in the gas, this will land at a specific wavelength with a specific number. This is an indication for the intensity, and these molecules will be back and evaluated. This application, now we don't see the slides.
You don't see?
No. Anyway, now we see, or want to see.
You can see the slides now?
Yes. This is a typical hydrogen blending application. This project we had in the US. This is not so young anymore, working properly, and the application is we measure the flow of hydrogen. We measure the gas volume in the downstream area, and this blending will be verified by Raman spectroscopy. What are the benefits of Raman spectroscopy? The measurements come much faster than from gas chromatography, considering you need hydrogen as parameter from the gas chromatograph. You need to wait up to 5 minutes, and Raman can provide measurements within 15 seconds. Imagine what could happen during this time. So it's essential to get the up-to-date information to shut down the process, preventing higher damages and an interest generally of safety. Exactly. Here you can see some CAD drawings of the compact skids of this solution. This is running quite well, and we have a nice comparison on the time with. Can you go to this, please?
This one?
No, to the mass spectrometry.
Yep.
Yes, exactly. This is a nice comparison with the mass spectrometry and Raman spectrometry, the reaction time, and it provides much higher safety for the process and process availability. Okay, next slide, please.
Yeah.
Yes, you can scan, you can see a video, interviews with these people, the reason behind. Yeah, next one, please.
Next one, I take over again. We are already at a certain summary, but for sure we will show you this soon online available process diagrams. So the target of today was to show that we are able to instrument different alkali PEM with the company NAPTA combination alkali PEM and high temperature electrolyzer. You saw some examples here. Then for sure, gas analytics wise, which is key quality for the 5.0. The trace humidity and trace oxygen example was shown from Norbert. And just recently, the slides for the blending of hydrogen to natural gas. We have much more to offer. For example, there is one ship, big ship. There's for sure more ships, but one ship is going from Australia to Japan, and we have in the harbor also installed. We call it ProServo. It's a displacer device for very precise measurement. In this case, for a huge tank of liquid hydrogen. So this would be a separate topic to look to other applications. And we have also just 2 weeks ago received the okay that we can publish from the company Linde, which is quite known, the level measurement of liquid hydrogen in smaller vessels with the capacitance probe. So these are examples for level measurement liquid hydrogen with ProServo, displacer, and capacitance. And one huge topic at the moment with electrolyzer companies is to discuss with them how can they have a certain predictive view, not only necessarily, it has also to do with the heartbeat, but how can they measure more with more parameters, how long the stack will live and what performance is. And this is one example here. No other company can measure directly after the stack the wet hydrogen flow. We have a patent with a vortex device which we use in steam application, and this is a little bit like the question with the differential pressure I showed you. The idea is now to take this software which evaluates different noises and calculates it and bring it from the steam to the wet hydrogen. Actually, this is not yet in this applicator process diagram because we have running tests which look promising. And then we give one additional parameter to the stack, the directly wet hydrogen flow after the stack before it goes to the gas separator. These are just examples. There are other measurements, especially in terms of electrolyte concentration, density, and so on, which we are discussing. So if one of you here has an issue or would like to go to stack optimization discussion, we are very happy, Norbert and me, to go in this and other topics afterwards separately. Last slide, before or second last actually. The target was to show you a little bit our overview of production, storage, transportation, and utilization. Utilization, we have here today focused on the blending for gas turbines. I mentioned also salt gas cavern application with lots of measurement to store it and then to get it out. And I said at the beginning, EcoVadis, this is a sustainability rating, which from independent companies is given to Endress Hauser and other companies, and we are proud that we are part of this rating, part of the 5% gold rated company, which means that we are not only talking about decarbonization, CO2 reduction, we also live it in our company. We are part in different associations, for example, the European Clean Hydrogen Alliance. And this I don't read, these are our commitments to from the Endress Hauser company, what we do for supporting the decarbonization. If there's any question now from your side, which I haven't seen, before I go to show the applicator process maps.
Maybe good time to to ask the question and to let the other to think about the questions. Mm-hmm. So I just wanted to actually ask both of you when you would have to list 3 crucial issues for hydrogen, which makes them for hydrogen devices. I mean, all from your portfolio. What you would say, 3 crucial issues in comparison with everything else, being methane, being other gases, and one question, but this maybe Jens you have in mind to answer it through additional slides. Comparison actually between different types of electrolyzers. So what is more applicable or what is crucial when you think of different type of electrolyzers, where to put and which outcome to have and so on.
Okay. So I start with the first one. Norbert, please add.
Okay.
Yes.
The three specific things. Number one is hydrogen is a specific element, and you have to take care in terms what I mentioned, diffusion. It all depends on the pressure and temperature. That means when you have only less than 10 bar, you can also use a pressure device with a ceramic. But what Norbert mentioned at the moment, we have a lot of discussion about hydrogen ready, which means today natural gas is used or another gas. And then in future, there will be a change to 100% hydrogen. And there it's a topic about having in mind the right material and the right sealing, not to forget. This is, I would say, number one. The material check, material selection for hydrogen applications. This would be my number one to take care when you have an application today and future. Yeah. Number two, Norbert, for hydrogen.
Yes, I'd like to highlight the regulation background. I had two experiences. The first one was if we put together a system working properly, it's not enough. You cannot use, and you have to consider all of the approvals and certificates are needed. In Austria, we had a case. Hydrogen is not defined in Germany as a burning gas. It's defined as industrial gas. So the national gas transfer certificate was applied by a project company. This project company delivered an electrolyzer to Austria. In Austria, we apply for gas transfer MI002. This is then the European Measuring Directive. And there may be differences between the approved technical parameters. In the PTV approval was the lowest density defined for hydrogen measurement with Coriolis mass flow meter of 1 kilogram per cubic meter. The process was designed for 3 kilograms per cubic meter, and in the MID certificate for that meter size was minimum defined 3.6 kilogram per cubic meter. And it was a quite tricky case without any flexibility, a lot of discussion. So my message is, if you are part of an international business, you need to always ask, you need to know where the journey goes to. And before ordering, you need to make sure that this approval and certification background is clear. You can save a lot of efforts.
Okay.
The second part is
Norbert, I think we have to look at the time.
Okay, maybe if you have time, or I can explain separately. There are many cases in my head.
I just want to answer shortly the number 3 points. The number 3 point is the safety. I mean, hydrogen is no rocket science. Companies in the chemical industry, they deal with hydrogen since several decades. The difference is, especially if you look at electrolyzers, you have hydrogen and oxygen, and there you have to take care. I mean, the hydrogen topic, safety-wise, is, as I said, no rocket science. With a possible combination of hydrogen and oxygen, there you need to take care. From my experience, there's always a certain concept of risk analysis there. There are a few companies, I will never give a name, they say, oh no, we have no explosion proof in functional safety. Long story short, is the number 3. I think the material topics, the regulation, and then the safety. And the other thing now with the electrolyzer, I make it very short. The combination of alkali and PEM is special. It's for small, medium ones. The big difference at the moment is if you look at the production of a huge amount of hydrogen, which has not the need of having 5.0, their alkali electrolyzers are used. PEM brings automatically 5.0, so this is then used for very dynamic application. The upscaling is also there to 100 megawatt up to in future 1 gigawatt, but alkali is simply today can produce more hydrogen from the principle. And the high temperature or SRAC is a little bit the hidden champion. They will come more because it has by far the highest efficiency of production and will be used when you have industrial like steam and other things. Last sentence is what is coming more and more. The efficiency will be increased when the heat from electrolyzers will be used. And we also are sure that more the oxygen will be used, so that then the whole electrolyzer will also bring more benefit. Carolina, were the questions answered? Over?
Thank you very much. Very clear and very good summary. Thank you very much.
Good.
Let's continue.
We have maybe 1 minute. I don't know, 1 minute.
Yes,
I like to share
yes.
again for
Yes,
this
go
applicator,
ahead,
which
please, because who wants to stay? I mean, many people still with us, and
Yeah.
it's going to be recorded and anyhow published
Okay.
on our website
Good.
together with slides.
Super. So can you see my screen now?
Yes.
So these are the 260 measuring points which I showed shortly. So we spoke about alkali and PEM. Let's go into the water preparation. And here we have then the different steps of water preparation, water cleaning, feed water preparation for alkali electrolyte preparation, and the wastewater treatment, not to forget. And if we go on here now, then it's a different level there of the application. And you will see the different measurements which then not yet are linked to the number 1, number 2. So therefore it's not online. We have here the tank, we have here the different pressure device, we have conductivity. And if I would click here, then you have not the different products. So long story short, we have all the different applications which are basically here. Here you can see what I said. If we have the water cleaning from preparation, reverse osmosis, it's a package itself, deodorization plant. Then you have here the link of alkali. From PEM comes a condensate back. And here you have the different other steps and the parameters that we get to know from water purification companies, especially for PEM, TOC, silicate more and more, conductivity as a must, and other parameters. Yeah. And the other ones, for example, here, this is then the one we go from the PEM, and then we go down to the individual applications. And this is all linked from the feed water preparation. Here goes the condensate to the water cleaning. All process diagrams are linked. Maybe as a last example, I don't know if it's interesting, but I mentioned it several times. We see in the usage, we had the gas turbine, but I like to show you here in the usage, the gas cavern storage. This is basically also mirrored this process diagrams we had a chance to discuss with customers, with alkali supplier, with PEM supplier, and also here with the salt cavern responsible. And this is overview. There are much more measurement. We focused on the key measurements here for the hydrogen pipeline, and then it's basically stored, and then afterwards it's getting out. And here, for example, we have 3 gas analytics trace measurement. One is a trace H2S, One is a trace oxygen and the other one trace humidity. So basically, in addition to what Norbert has said, trace humidity, trace oxygen is here, and we have also trace of H2S. So this is typically the basic measurements for gas cavern storage of hydrogen. Okay, Norbert, I think we could go. And what we can offer, I would say afterwards, is if you are interested, we can do also separate meetings to go in. We use this already for discussion of what is the best fit to use. So this is not yet online because I said 260 measuring points need to be described in best product and then alternatives. But when you are interested, we can have follow-up meetings. Yeah. Norbert, anything to add from your side?
Yes. So this is a knowledge session for DSO, distribution system operators. So you have for sure processes in today's session. You have seen you are not in daily business in touch with, and this tool will provide general knowledge for you, general overview, what is happening, because what I said last year in a gas event, this is not anymore the case. I am natural gas only. You will be concerned at least what's happening in this container on my side, and this is a great information. Generally, you will be able to make the basic configurations for further processes. You can use it in the future, of course, free of charge. This is manufacturer independent. It's very important. And yeah, so I'm very glad that we got this invitation and had the opportunity to present today for you.
Thank you very much. Thank you both, really, for sharing this accumulated knowledge and experience with us and with our audience. I can say not only from contracting parties of the energy community, but also from European Union member states, all who are interested in new gases and new obligations, actually, which will come to the companies. The idea of this entire webinar is actually to show that, as I said at the beginning, that technology exists, that experience exists, that some issues underlined and not solved yet, but on the way to be solved in parallel with this legislation, which somehow is core of the energy community. That's why we always start from legislation. But that was the idea, really, to show technical details, experience, and knowledge. We will publish presentation. We recorded this webinar. This is also going to be published on our website, so you can always come back. You can check. You have details of our presenters there, and of course you can come back to them directly or through Energy Community Secretariat, or raise maybe and underline other issues which we didn't have so far in those three webinars. And from my side, I only can say deep thank once again to our excellent presenters, and see you in autumn with further topics. In the meantime, I wish you all great summer break, and come to autumn with fresh ideas and to see what we are going to do next. So thank you very much.
Thank you also for the opportunity. All the best, good summer break, and most important, health. So.
Yes.
Okay.
Thank you.
Bye-bye. Thank you. Bye-bye.
Thank you.